This essay is not a technical specification or a market forecast. It is an architectural history written at the level of constraints and trade-offs. Familiarity with blockchain concepts is assumed, but no prior knowledge of Xenon is required. The question that went unasked. There's a question crypto never thought to ask Bitcoin. Not because it was hidden, but because everyone assumed the answer was already known. How would Bitcoin do smart contracts? Not how could Bitcoin imitate Ethereum? Not how could Bitcoin bridge into execution-first systems? But how could programmable money exist while preserving Bitcoin's rule that verification must remain cheaper than execution? That question disappeared around 2015, quietly replaced by the assumption that global execution was the only path forward. A fork in thinking, not code, rerouted an entire industry. Bitcoin's real invention. Bitcoin's breakthrough wasn't digital money. It was a new definition of truth. In Bitcoin, truth doesn't come from computation. It comes from ordering. Every node performs a simple ritual. Check signatures. Confirm transaction sequence. Update balances. That's all. Verification is local, independent, and accessible. No node re-executes history, it validates it. Truth emerges from a timeline everyone can check for themselves. This constraint, verification as a right, not a privilege, became the soul of Bitcoin. It limited expressiveness, but guaranteed integrity and universality. It's why your grandmother could theoretically run a full node on outdated hardware and know what's true. Not trust, no. When truth began to mean execution, Ethereum changed the question entirely. Not how do we agree on what happened, but how do we all run the same program together? Execution moved inside consensus. Every node repeated every instruction so the world could share one state machine. The result was extraordinary. Programmable money became programmable everything. Loans without banks, art without galleries, games without servers. But it inverted Bitcoin's equation. Truth now came from running code, not verifying sequence. Verification became as expensive as computation itself. What Bitcoin made accessible, Ethereum made powerful. What Ethereum made powerful, it made expensive to verify independently. Full participation began to drift beyond the reach of average users. The property that made Bitcoin trustless became premium infrastructure. Most people stopped running nodes. They started renting trust. The decision tree, nobody walked. If you start from Bitcoin's constraint, verification must stay cheap and independent. And ask how to extend functionality, 9 distinct paths appear. They form a decision tree of trade-offs. Most of the industry walked only one branch. Here's what they missed. Path 1, global virtual machine. The choice, every node executes every transaction. Consensus runs code, not order. All systems like Ethereum, Solana, and Avalanche live here. What you gain, transformation through computation, smart contracts, DeFi, composability, the entire programmable economy. What you lose, universality of verification. Running a node becomes a job, not a right. Verdict, effective. But it breaks Bitcoin's core rule. Path 2, minimal script expansion. The choice, incremental evolution. Add bounded opcodes like or covenants. Stay inside Bitcoin's UTXO model. What you gain, security and philosophical alignment. What you lose, expressiveness. Still too narrow for dynamic applications. Verdict, secure and principled. Insufficient for general computation. Path 3, off-chain channels. The choice, perform execution privately, settle on-chain only if disputes occur. Lightning Network proves this can scale payments beautifully. What you gain, privacy, speed, and low cost for bilateral interactions. What you lose, global state. Channels are between two parties, not the whole world. Verdict, ideal for payments, unfit for shared applications. Path 4, sidechains and federations. The choice, Shift complexity to auxiliary chains connected by bridges. 3 flavors. Federated pegs. Trusted custodians sign withdrawals. Merged mining. Shared hash power. Weaker independence. Drive chains. Miners vote. Security depends on honesty. What you gain, flexibility and experimentation. What you lose, don't trust, verify. Every version relies on trusted intermediaries. Verdict, pragmatic. Philosophically fatal. Path 5, roll-ups. Proof instead of re-execution. The choice, what if the base layer doesn't re-execute transactions, but verifies proofs they were executed correctly? This is the conceptual pivot that changes everything. 2 interpretations emerged. Optimistic roll-ups, fraud proofs. Assume correctness, challenge if wrong. Works but needs watchers and time delays. Validity roll-ups, zero-knowledge proofs. Each batch ships a cryptographic certificate of correct computation. Verification cost depends on proof size, not program length. What you gain, Bitcoin's asymmetry restored. Verification less than execution. Heavy to produce, cheap to verify. What you lose, nothing fundamental, only complexity and implementation. Verdict, the only branch that fully preserves Bitcoin's principle while enabling general computation. In this essay, proof-based does not imply a specific primitive like snarks, but the broader principle that correctness is verified through compact commitments to ordered state transitions, rather than global re-execution. Path 6, client-side validation. The choice, each user validates their own state. The chain stores only commitments. What you gain, privacy, scalability, and minimal on-chain footprint. What you lose, shared truth. No global view everyone agrees on. Verdict, great for assets. Unfit for global coordination. Path 7, sharding. The choice, divide the network so each node verifies only part of it. What you gain, throughput rises dramatically. What you lose, universal verification collapses. No one can see everything. You must trust others verified their shard correctly. Verdict, efficient. Philosophically fatal. Path 8, DAG consensus versus meta-DAG ordering. The nuance here matters more than people realize. DAG consensus, replace linear blocks with a graph of transactions. IOTA, nano. Without a single canonical order, double spends resolve probabilistically. Most require coordinators to stay stable. What you lose, deterministic truth. Verdict, loses Bitcoin's most important property. Meta-DAG, ordering use a DAG shape within a consensus backbone to improve sequencing while preserving a single canonical order. This maintains Bitcoin's deterministic property while opening parallel throughput. What you gain, efficient ordering without sacrificing truth. Verdict, philosophically aligned. Rarely attempted. Path 9, UTXO extensions and covenants. The choice, expand local expressiveness in Bitcoin's own model. Template commitments, staged withdrawals, atomic pools. What you gain, valuable primitives within Bitcoin's trust model. What you lose, generality. Still bounded scope. Verdict, compatible evolution. Limited range. Mapping the outcome. Now reevaluate each branch under one constant. Anyone should be able to cheaply verify everything that matters. Only a few survive. Minimal scripts. Off-chain channels limited to bilateral use. Covenants. Client-side validation. Limited to personal state. Meta-DAG. Ordering checkmark. Proof-based systems. Every other design either centralizes trust or burdens verification. Only proof-based and ordering-first approaches sustain both generality and accessibility. The industry chose power over access and called it progress. The black hole of execution. Ethereum's success pulled the industry into an execution-first gravity well. Projects competed on throughput, higher TPS, richer VMS, deeper state. Each improvement deepened dependence on infrastructure. Verification became something to outsource, a service rather than a birthright. The narrative shifted. Decentralization became about validator count, not verification accessibility. Trustlessness became about cryptographic guarantees you couldn't personally check. Crypto scaled computation and inadvertently shrank participation. The black hole glowed bright, but it consumed its own premise. We built a financial system you need a data center to independently verify, then called it permissionless. The only two chains that understood. Across thousands of blockchain projects, only two have enforced verification as the primary architectural constraint at the base layer: Bitcoin and Xenon. Not because they share code or philosophy by accident, because they both answer the same fundamental question the same way. What if verification must stay cheaper than execution? Always. Every other major chain inverted this relationship. Ethereum, Solana, Avalanche, Cosmos, Polkadot, all execution first by design. Verification became a byproduct of computation, not its precondition. Bitcoin and Xenon stand alone in treating verification as the architectural foundation, not a feature to preserve, the constraint that shapes everything else. Why this matters? The difference isn't academic. It's the difference between a system anyone can verify and a system only engineers can audit. Execution first chains. Truth emerges from running code. Verification cost scales with program complexity. Full nodes become infrastructure. Decentralization becomes aspirational. Don't trust, verify becomes trust our RPC endpoints. Verification first chains. Truth emerges from ordered events. Verification stays bounded and simple. Full nodes remain accessible. Decentralization stays structural. Don't trust, verify stays literal. This is why Bitcoin never needed a roadmap to improve decentralization. It was designed so verification couldn't accidentally drift into privilege. Xenon is the only chain to inherit this property while extending capability. The architectural kinship. Bitcoin's design can be summarized in one constraint. Every node must be able to verify everything without repeating execution. Xenon's design follows the same rule through different structures. Both systems share the core insight. Order transactions canonically, then let anyone verify the result. Execution is optional. Ordering is mandatory. Truth is accessible. Why Xenon can verify Bitcoin natively? Because they define truth identically as deterministic ordering. Xenon can validate Bitcoin's state without intermediaries. No bridges, no wrapped tokens, no federated signers. Just direct cryptographic verification of Bitcoin's chain inside Xenon's consensus. This is impossible with execution-first chains because they fundamentally don't speak Bitcoin's language. Ethereum verifies truth through EVM state transitions. Bitcoin verifies truth through UTXO ordering. They're incompatible at the axiom level. You can't directly verify Bitcoin inside Ethereum's consensus without re-implementing Bitcoin's validation logic inside the EVM. That's not native verification. That's emulation. Wrapped in trust assumptions about whoever deployed the contract, Xenon and Bitcoin share axioms. That's why one can directly read the other. No translation layer. No trust boundary. Just math. The path not finished. By 2018, cryptography and network theory had advanced enough to make verification first viable again. Merkle and SPV proofs made light clients practical. Deterministic DAG ordering solved parallel throughput without losing canonical truth. Succinct proofs made expensive computation verifiable cheaply. Together, they resurrected Bitcoin's asymmetry, heavy to produce, cheap to verify. Execution could be local and optional. Verification could be universal again. The technology existed to preserve Bitcoin's soul while expanding its body. The larger industry, hypnotized by throughput, never walked that road to the end. Almost. The cousins, not competitors. Xenon isn't Bitcoin with smart contracts. It's the answer to the question Bitcoin implied, but never needed to ask itself. What if you built this architecture from scratch today with modern cryptography, knowing what we know now? Bitcoin optimized for a 2009 world. limited bandwidth, uncertain adoption, maximalist simplicity. Xenon optimized for 2018 forward. Merkle proofs, lighted clients, account models, parallel ordering, but both optimized for the same invariant. Verification must remain a right, not a service. They're not competing. They're the only two members of a family no one else bothered to join. Bitcoin is the proof it could be done once. Xenon is the proof it wasn't a historical accident. What the industry missed. The crypto industry treated Bitcoin's constraint as a limitation to overcome. Xenon treated it as a principle to extend. That's the entire story. One path led to execution maximalism, RPC dependency, decentralization as marketing, trust assumptions hidden in infrastructure. The other path led to verification first architecture, personal node operation, decentralization as structure, trust you can actually verify. Thousands of chains were built. Two remembered why any of this mattered. Verification given back to people. The industry scaled execution, but ignored verification inclusion. We celebrated million-dollar JPEGs while losing the ability to independently verify they exist. True scalability isn't measured by transactions per second. It's measured by verifiers per second. How many people can know what's true, not just trust what they're told? When verification becomes personal again, decentralization becomes tangible. Everyone can carry truth in their pocket. Not a wallet that queries someone else's node. A wallet that is a node. That's the quiet revolution the ecosystem forgot to finish. The timeline everyone missed. 2009, Bitcoin proves ordering truth on heavy hardware. 2015, Ethereum proves execution applications, but verification bloats. 2015 to 2018, industry copies the execution first model en masse. 2018, MetaDAG architecture revives verification first quietly, without fanfare. 2020, Solr's bridges and wrappers reveal their custodial cores in exploits and collapses. 2026, verification first ideas resurfaced in public consciousness. History didn't end. It drifted into the branch no one walked. The question hung in the air for years. How would Bitcoin do this? The answer was built. No one noticed. The return of personal verification. Bitcoin gave truth without trust. Ethereum gave logic without permission. Now comes verification without infrastructure. Decentralization was never about throughput. It was about independence. Verification first closes that loop. It turns philosophy back into practice. It lets anyone prove what's true. Not with a PhD, not with a server farm, but with a phone. The cousin that remembered doesn't compete. It completes. It reunites the split between ordering and execution that began this whole experiment. Verify Bitcoin. Don't bridge it. That's the question no one bothered to ask Bitcoin. And once you see it, you can't unsee it.